Hello, everyone, and welcome to our presentation. My name is Janine Donnelly. I am the Manager of Webinars for IBM Systems Magazine, and I will be the moderator for today's event. Today's webinar, Mainstreaming the Mainframe, Can It Be Just Another Platform?, is sponsored by Compuware. Today's featured speakers are Jim Liebert and Stephen Kansa. Jim Liebert is a product manager at Compuware. He has extensive development experience with both established and startup software companies. At Compuware, Jim is concentrating on improving data and program analysis. Stephen Kansa is also a product manager at Compuware. Stephen has extensive experience in agile application development across a wide variety of technologies and industries. Working with Compuware's Topaz products, Stephen is focused on enabling modern DevOps capabilities for mainframe technologies. Today, Jim and Steve will discuss how the mainframe's tools, processes, and culture must evolve so it can serve as just another agile platform in the multi-platform enterprise. With our introductions complete, Jim, I will turn the presentation over to you.
And towards the end of this WebEx, we'll pop up a brief survey that's fairly painless, and we'd really appreciate it if you would fill it out. And to entice you to do that, there is also a potential of winning a $50 American Express gift card. Now, the huge percentage of this WebEx will be a live demo because we feel it's much better to show you rather than tell you. But before we start in on the live demo, I'd like to take a step back, and in regard to this mainstreaming the mainframe, I'd like to ask one harsh question. Why does it matter? Who cares how fast mainframe development occurs? Well, the fact is that the mainframe ecosystem is currently very vibrant. It's a little subterranean in that most of the internet isn't aware of it, but many transactions eventually end up on a mainframe. All roads lead to the mainframe. Unless you're dealing with social sites or perhaps searches, anything financial is almost guaranteed to end with a mainframe. Anything involving a government or insurance or travel or distribution, all roads lead to the mainframe. And proof of this is if you just take a look at IBM's quarterly earnings statements. The most robust part of IBM's earnings is still in the mainframe hardware business. Now, does that correlate to more customers getting mainframes? Well, that I'm not sure about, and that might be a discussion for another WebEx. But what it does mean is that sites that have mainframes are continuing to see the value and are continuing to invest in them. This has led to kind of an awkward paradigm, though, in that open systems development has matured over the last decade or so to be very aggressive, very fast-paced, built on the agile methodology and DevOps, just for quick turnaround to produce output as quickly as possible. While the mainframe systems have tended to stay where they were decades ago, where it's still waterfall development, huge 12-month cycle to produce releases, and it's just that, measure twice, cut once methodology that's always dominated the mainframe. And this has become so prevalent that this even has a term. It's often referred to as the bimodal IT. Now, what we at Compuware, we feel that this is not the appropriate approach. And for a long time, we were just a voice in the wilderness expressing our dismay at this approach. And as you can see on these quotes on the bottom of this slide, we're starting to get some momentum with analysts and trade magazines where they're starting to see a flaw in the system. And the fact is that IT progress can only go as fast as the slowest component. It's kind of like that, the chain is only as strong as the weakest link. And the other thing is that, you know, the mainframe demographics with the aging mainframe developers just makes this totally untenable. We really need the mainframe to join that open systems community and use the same development methodology. And in a lot of cases, there is a huge pent-up energy in the mainframe and a vast potential in the mainframe. And what we're suggesting is that by moving to a blended ecosystem where both open systems development and mainframe development are using the agile approach, DevOps methodology, and you know, more aggressive release cycles, you can achieve the best results with your overall IT progress. And like I say, it's been encouraging to see that we're getting acknowledgement from analysts and from trade magazines, but probably more important for us is that we're also getting validation from our customers themselves. They're seeing value in our approach to mainstream the mainframe.
So in our goal of supporting a DevOps approach with the mainframe, and one of the key things we want to do, as Jim said, is make it easy to go fast. In organization's evolution towards that, we see there's some key milestones and key things that we've seen customers have success when they put these in place. And one of the starting points of that is an Eclipse-based interface. And what this allows you to do is have a common development IDE across technologies. So it's not a case where a certain team works on one IDE and then the mainframe team works within a green screen. The Eclipse-based interface provides that platform that allows people to interoperate and have a similar collaboration experience. Another key step is advanced application analytics. And what this does is it gives you the ability to understand and break down applications. A lot of times mainframe applications are large systems that have evolved over the course of many years, and there's a lot of knowledge that may be retained in the code, but it may be difficult to understand how that code operates. So the advanced application analytics give you the capability to break things down and determine what modifications you need to make so you're not spending all your time in an analysis paralysis. And then as you increase your throughput, you need to have source code management systems that'll support a modern development and deployment lifecycle and enables things like continuous integration and continuous delivery methods. And if you're tied to a system that's designed around a waterfall approach, it really becomes a bottleneck in you moving to a DevOps lifecycle. Another critically important thing is as you're evolving your applications, you need to maintain that high quality aspect. You can't afford in your systems of record to have quality issues. So maintaining high quality and also managing your technical debt as you evolve these systems is really a key component of sustaining your pace. Speeding up testing cycles also means that you have to look for additional automated testing methods, but it also is critical to have transparency and drive your process around key metrics to ensure that quality is baked into your process. And then lastly, DevOps requires a culture that enables people to cross-communicate across organizational boundaries. And having tools that people can collaborate from the operations side and the development side helps really tear down the walls that may have existed across organizations. Now at this point, Jim is going to walk through some of our capabilities, touching on the application analytics side.
Thanks, Steve. And what I'm going to emphasize is the use of visualization to increase application understanding. And really the initial intent here was that a programmer new to the mainframe, how can they have kind of this automated mentor to get the background necessary so they can make changes with confidence? And really, the first thing we're going to talk about is what's known as the runtime visualizer, and the specific use case we wanted to do for this is that very first step, right? Oftentimes that's the absolute slowest step in the development process because you have to overcome that inertia and get the ball rolling. And with the runtime visualizer, what we introduced is the ability to point Compuware at an execution, whether it's a CICS transaction or an IMS transaction or a job step, and we'll watch it run, and we'll record all of the program interactions, programs calling programs, returning, all of the file I/O, so whether it does I/O to MVS files or IMS or DB2, and the sequence that those events occur in. And you can view this live, but you can also save it off and replay it at a later date. So you can actually understand what actually happened as that program was executed. And that's what I'm going to do now is I'm going to replay one that I had previously recorded. And I'm going to replay it at a slightly faster rate. But you can see here that those blue highlights indicate that there's programs calling programs and that there's I/O being done against files and DB2 tables. And it's just showing you the execution flow of this particular, in this case, this happens to be a batch job step. And the nice thing about this is what's known as dynamic analysis, where this is actually what is occurring during the execution. This isn't theoretical. It's not using the source code. This is actually watching the execution itself. And now it's completed, and you can see my whole picture here. And now, for instance, if I click on one of these DB2 tables, it'll give me information on that table, the subsystem name and the owner and the name of the table. If I hover over one of these counters, it'll give me the occurrences. So in this case, the main program demo called RVII 40 15 times. If I hover over the connector between the program and a DB2 table, it tells me that this did 15 as SQL selects. Over here, if I hover over this DB2 table, it tells me that it did 3 open cursors and 21 fetches. If I look at this flat file, it tells me that it did 1 open and 16 reads. And to get even further depth, if I happen to click on one of those entries, it'll tell me, over on the bottom here, it'll show me the event that is the first occurrence of that program call. And again, these events are currently in chronological order, so I can just march down the list and see what happened next to get a feel for the order that things are occurring in the program. Again, the whole intent here is to give, or the whole initial intent here was to give that less experienced mainframe developer a starting point. What we've actually found as this has gone out to customers is that this has even found a home with the experienced mainframe developer, because oftentimes, and I'm sure, I was a developer for 20 years and I can vouch that this happened to me often enough, is that my understanding of the application and what really happens, those two might not exactly have jived. And now this is unequivocally telling you what's happening in this particular case. And we've even had instances where sites have seen that, for instance, they're doing many more SQL calls than were necessary. In one case, a site was able to locate where they were doing 10,000 SQL calls in an execution when really only one was needed. So there is a potential in this runtime visualizer to use it in many use cases. Here, if we go back to the use case where the programmer wants to make a change to an application, let's say it's the ordering system and they have to do something specific with the ordering system, here they can run it and they can see what actually happens during an execution. The next step is they might want to take this execution and now begin to hone in on the programs they specifically want to change. In this case, we've introduced because another objective we're trying to do is application understanding through visualization, but also making the programming experience for a COBOL programmer using Eclipse similar, if not identical, to that Java programmer using Eclipse. So when a person becomes a hybrid programmer, or sometimes called a polyglot programmer, where they're moving from Java to COBOL, the changes are seamless. So what we introduced here is the ability to create projects that contain COBOL programs, and you can control what programs are in your project. And a good use case might be you run the runtime visualizer, you take all those programs, and you create a project. And then just like you can in Java, you can get hierarchical information, you can do the same thing with the COBOL programs, where in Java you might get class and type hierarchy. Here we'll give you program and copybook hierarchy. So here I right-clicked and selected Show Hierarchy, and at first it tells me the programs that PDA 014 calls, and I can continue to drill down and see what programs those programs call. And then I can flip the order and actually show me what programs call PDA 014, and then what programs call that program. So we can begin to see the hierarchy of programs, and likewise we can do the same thing with copybooks. What programs include what copybooks do those copybooks include? And again, now this is static analysis where we're getting this information from looking at the code. So now we've kind of segued from what really happened into what could potentially be happening. And we can just, by double clicking on an entry, we can bring it up in the editor. And so now we're continuing to hone in, where first we started with everything that got executed during a runtime, and then we built a project with a subset of programs, and now we're honing in on one specific program. And here, if we right-click and select Perform Program Analysis, we can get visual help on this program as well. On the bottom left, we get kind of a summary of this program. So at a glance, we can see that it's accessing one file and two DB2 tables, where maybe a second ago we knew nothing about this program. Now we know who calls it and who it calls, and now we also know where it's getting data sources. On the upper right here, part of program analysis is we went through and built a dynamic structure chart, so we can see the structure chart of the program and what paragraphs call what paragraphs. This happens to be a COBOL program. Had it been a PL1 program, that would be which procs call which procs. And you'll notice it's colorized, so we can actually control what the color means. So let's say we're interested in what paragraphs call subroutines. So we can change the colorization to isolate the specific paragraphs that call subroutines. And I think you can notice that one of these is not like the others, and so all the subroutine calls are happening out of this one paragraph. And if I click on that paragraph in the visualization, it'll take me to that line of code in the editor. So you can use the visualization to actually see the code. So you can navigate through the code using the visualization. The second level of visualization here is what's known as logic flow, and this works at the paragraph level, and again, it's showing us visually what's happening in this paragraph. So the first thing is that there's an if statement, and if you notice, I clicked on the if, and it took me to the if on the line of code, and if it's true, I go to line 1118, and really what we're trying to do here is kind of abstract the logic from the programming language. So we're just making the only difference between Java development and COBOL development is the actual syntax of the language itself. And you can understand it visually without having to get caught up in the syntax of COBOL itself. Another powerful visualization here is if I click into a field, in this case I've clicked into this PDAS01OD-year field, it'll give me information on that field. So the first thing it's showing, let me go to data flow. First thing it's showing me is that that field is set from a field called WMF date-YY. And if I click on the connector, it'll take me to the line of code in the program where that field is set. But I can also expand the information available to that field. So if I click on this question mark icon, it'll now show me where that field is used in comparison. And again, if I click on that connector, it'll take me to that line of code. This next one will say, show me fields, aliases is, of course, the COBOL term, show me fields that occupy the same place in storage as my field of interest. And you can see we're starting to build a much broader story of the role that variable plays in this program. And then finally, we can take it to the utmost degree and just don't show me fields that affect that field or are affected by that field, but take that out another layer. Show me fields that affect the fields that affect that field. And now you can see we get a complete picture of how that field is used in this program. And just imagine if you were the programmer and you were charged with changing that field, maybe lengthening that field, for instance. And if you just did a cursory glance, it would look like that change would have been rather subtle. But as we expanded our horizons of what we were looking at, you can see that we actually have to take quite a bit into consideration, and not the least of which is, you know, if we look here, there's also another program involved. So that field is eventually getting passed to another program. So we'd have to broaden our horizons to actually take a look at how that program is using this field. And now that, you know, we're showing it visually, but we can also display it in a table. And this table, you could almost use this table as a to-do list if you were charged with changing that field and just kind of check off each of these that, yes, I've considered that one and I've taken it into account with my changes. And again, what we're trying to emphasize here is the use of visualization to increase application understanding and ultimately to increase the cadence of mainframe development. So the mainframe developer now has the tools so they can develop in an agile methodology and as quickly as the open systems developers. And in many cases, you know, not only are we proposing this as a solution, but we're living this at Compuware. We've been agile now for 18 months. We've released a new product every 3 months, and we have our mainframe development staff keeping up with our Eclipse developers and keeping up with our web developers. And this visualization, understanding through visualization has really been a key ingredient. The second part, the other side of the coin here to increase that cadence, is to make the tooling equivalent across open systems and mainframe development. And here I'm going to pass control over to Steve so he can walk through how we've taken steps in that direction.
Okay, and while I'm enabling my share, we have a question from the audience. Maybe you can answer while I'm enabling my share, and it's, is what's been shown with program analysis and the runtime visualizer, is that also able to debug an issue?
I think, you know, that's an interesting question because really oftentimes the first question we get is, how'd you get that information? And as you might suspect, and as this question is leading you, is we're using expediter technology to acquire that information. And really, what you can do is during an expediter Eclipse session, you can activate visualization. So as you're debugging the program, you can see that visualization build. So for instance, if you stop at a breakpoint, you can go and see what programs have been called so far, what file IO. So you can use it to drive debugging at a certain level.
Okay. So I'm going to show one of our integrations that we announced in January. And there are two parts of this integration, and I'll show both parts of the integration. But the integration is with SonarSource. And SonarSource is the company behind tools like SonarCube. And they recently also introduced a solution called SonarLint. And what SonarLint does is it gives you the capability directly in your IDE to get feedback on potential code issues as you're coding it. So let's for a minute, take the scenario that Jim walked us through. So we've identified a particular piece of COBOL code that we need to modify in order to support a new business transaction. So in this case, I've enabled SonarCube integrated inside Topaz Workbench, and I've modified some code. And in this particular case, I have checked the response code, and based off that response code, I'm pushing a sequence value to prioritize something in my ordering system. So I've made the changes right here, and as I save those changes, I get instant feedback from SonarCube. And what's happened in this case is, in me making that change, I've missed something. I made a syntactical error in the code, and it's detected instantly. So I can see I have a critical issue, and the critical issue is in moving data from one field into another field. I missed the fact that I'm moving data from a numeric field into an alphanumeric field. And being a little bit new to COBOL, I might not know exactly what I did or how to fix it. And what I'm able to do is get information from SonarCube, which is a repository of best practices across languages. And I can see here that in making this type of change, I can either yield strange results or, at best, or potentially a crash. And in cases like this, I may be able to test this with a data set, and I might not have a particular piece of data that would cause one of these things. And that issue could go on from development, it potentially could get through QA, and it might cause a crash in production. So having SonarCube here, I'm able to see that I've introduced this issue, and then I can also scroll through and I can see a potential solution. So in this case, what I would probably do is use a couple additional COBOL commands to cast that numeric value into the alphanumeric as a numeric value and address that issue. The other thing that SonarLint will give me is analysis not only on the changes I've made, but also changes that, or potential issues that have existed in the code for a while. So in this case, I've modified a file, I made a change recently, but I've also introduced some other issues. So now as a developer, I'm able to understand this, go through these issues, and make any corrections that I may need to before I check this code in. And this capability exists on an individual file, or if I click at a higher level, I can see all the programs that exist in this project and the issues that may exist in it. So the other aspect of this is that's good for me as a developer, but I'm on a team and I'm working across other teams in IT, and I need a capability to understand where things are at holistically, and that's where SonarCube comes in. So as you can see here, SonarCube is a web-based dashboard and reporting system that allows you to manage your quality and manage your technical debt. So in this case, I have multiple different projects that I'm working for, and I can see the technical debt across those projects. So in this case, I have a web order management system. I can see that there are still 5 blocking issues on this, but the overall technical debt is fairly low. In another situation, I have a finance application, and this is more of a legacy application, and it's got quite a few issues that have built up over the course of time. And what I can do inside SonarCube is drill into those issues and see what the issues are, and then allow me to manage those issues over the course of time. We realize that people that have legacy applications, it's not wise to go through and just spend all your time trying to address technical debt. And sometimes some of these issues may not be something that you need to address. So within SonarCube, it gives you this platform to manage these issues over the course of time. Now, this type of reporting system is very commonly used. I think a metric from SonarSource is that almost 60% of Java developers use SonarCube daily in their work. The challenge that was brought to us by customers in working with SonarSource was that for mainframe development, it was not easy to drive this type of analysis. It was essentially up for customers to develop their own custom integrations to get COBOL code analyzed by SonarCube. So what we did in consultation with our customers is they said, hey, you know, in situations where I'm using Java or other technologies, JavaScript, I'm able to drive a continuous integration process to constantly analyze my source code as I'm making changes. And I'm able to do that with Jenkins. And Jenkins, great flexible tool. It works with every source code management system except the mainframe source code management systems. So what we've done, and this is available as you can see here, we've created a plugin for Jenkins that allows you to integrate Jenkins into Topaz and connect with Topaz. And then Topaz performs is that kind of key gateway that allows you to interact with source code management systems like Endeavor, like ISPW, or if you're not using a traditional source code management system, an older one, you may have your source code in PDS data sets. And we allow you to interact with all of those. So what that looks like is you can now define a Jenkins job that will go off, interact. In this case, I have this configured to interact with a ISPW system, and I can specify the data sets on the mainframe that have my source code. And this plugin will interact with Topaz and pull down that source code. And then it's just like Java, you can easily integrate SonarCube's analysis to run the analysis and push metrics into Jenkins. So in this case, I've set this job up to run every 2 hours, every day of the week. So as people are working on the project and checking in code, I'm able to see the status and people are able to manage those issues. So I have a constant heartbeat on the quality of my code base as it's being moved forward in a very rapid fashion. And this is really, we think this approach is very key to become agile, to become an organization that is able to deliver and move applications forward to meet business needs in a rapid manner. So at this point, we're going to cut back into the presentation and then allow some time for questions. So although in this webcast we focused a lot on the development aspects of our DevOps approach, I would like to point out that we do have a comprehensive suite of solutions with our Topaz suite. And then we've embraced partnering with other leading vendors in the DevOps space to really allow the mainframe to be just another platform and to integrate with tools that people are using very successfully on other technologies. And again, this approach with Eclipse, with Web, with integrations is really our approach to make the mainframe be just another platform and participate in mainstream development practices. And we think this is a critical thing for today's digital economy. I'd like to share this quote from one of our customers that we worked with very closely in developing the SonarSource integration. And this customer views this ability to have agile in DevOps approach on both their mainframe and distributed technologies as a competitive advantage. It allows them to move quickly, to leverage their intellectual property that they built up over the course of time and move it forward to meet new business demands and deliver new business capabilities. And they felt it was very important for their teams to be able to have access to the same types of approaches. They have what they call full stack developers that are able to work from JavaScript and Java and also participate in a mainframe development ecosystem. And they don't have to go and learn a totally different set of tools based off the platform they're working on. They're able to leverage the same types of tools like SonarSource and Eclipse, regardless of platform. And they felt with us partnering with SonarSource, we've really enabled them to focus more on their business versus managing diverse sets of tool stacks or trying to implement a single stack that covers everything but may not be best in class across the board. Last thing I want to touch base on is in this webcast, we touch base on some of the application analytics and the integration with SonarSource, but we do have some upcoming webcasts. So in March, there'll be a webcast on what's new in Topaz Workbench, and Topaz Workbench is our new release, which combines our previous releases of Topaz and our previous releases of Compuware Workbench into a single deliverable that allows you to enable functionality based off what you desire within a Eclipse or within our own Eclipse-based RPC. And in the future, we're also going to be sharing additional content on our source code management systems.
All right, thanks, Steve. And I just want to mention that you might have noticed that we went through this at kind of a breakneck pace. So if we didn't cover something as completely as you would have liked, or probably more importantly, if we piqued your interest on something, please reach out to Compuware because we'd be more than happy to talk to you. That, you know, because we're now agile, we're really, you know, searching for customer validation on absolutely every feature we put out in our products. And so, like I say, if this interested you, or maybe even more importantly, if you kind of saw it and go, this would be much more useful to me if only it did this, that's the kind of feedback we'd love to get. And speaking of feedback, I just kind of ask you to indulge us and fill out this survey, and that would help us understand where you're currently sitting in this kind of environment. Now, we've been getting some excellent questions, and we're going to try to rip through these as quickly as possible. Some of these I probably could have covered, but didn't. One question that came up is, can you do this runtime visualizer in production? And kind of the short answer is yes, and the slightly longer answer is you know, I kind of mentioned in passing that the plumbing we're using is Expediter, and also we're using part of Abendate as well. So you'd have to be able to run Expediter in production, which some sites are set up to do that, and other sites are not set up to do that. And also that, you know, no measurement is free, so this isn't something you would turn on and just run all day, every day. It's more for isolated events when you want to get added information about specific executions. And it does not require source code, so you don't have to have your source code enabled to use the runtime visualizer. And, you know, my example was COBOL specific, but it'll show you program calls of various languages, whether static or dynamic. It just so happened my example was all COBOL.
So I see we have a couple questions regarding unit testing and automated unit testing in Topaz. And I think that's something that we will directly reach out to some of the people that are asking these questions and get feedback from you in terms of what you're looking for in those capabilities. So as Jim mentioned, as part of our agile development lifecycle, we actively want to work with customers, and automated unit testing is definitely an area that we really want to engage with people on, understand what the specific challenges are for mainframe testing, and also talk about some of the potential solutions that we're looking at in that area. So it's definitely an active focus for us, and we really look forward to engaging with those that have asked.
A couple other questions here are really talking about some futures. Like one asks, would we be able to track a transaction as it's passed through a distributed and then onto the mainframe, and maybe using an MQ trigger to trigger a CICS transaction? And that's all under consideration, and so watch this space. Another question was, and this is really a good question too, is those of you that are dedicated Compuware followers might know that we've had a tool called the Compuware Workbench that's been out for probably 6 or 7 years now. And the question is this the Workbench or is this something new? And the answer is that this is actually something new. If you want to, we have rebranded the Workbench to what's known as Topaz Workbench. And if you're interested in the progress we've made with the Workbench, that's that next webcast that Steve mentioned passing that occurs in March.
There's also a question on, does it require a connection to a source code repository? And the answer to this is Topaz Workbench leverages a capability we have called Host Explorer. And Host Explorer communicates with a technology we have on the mainframe to handle communication with Endeavor or directly to PDS files. So it also deals with ISPW. So really the complexities of that in communicating with the mainframe are dealt with within our solution. And as you saw when we were demoing, it's very easy to explore data sets on the mainframe and pull those data sets that contain source code into a project and start editing that in Topaz Workbench, just like you would similar capabilities as it's with Java projects in Eclipse.
Another question, and this is often what we get when we show this to customers, is that the portion of the room that has Java development experience immediately gets Jenkins and SonarCube. And the portion of the room that are more traditional mainframe people, they see what it's doing, but they don't exactly see the benefit. And what I can say, what we see here is that as we make changes, we can automatically get an indication of whether those, kind of the danger level of those changes. So we run the Jenkins orchestration to push the quality of the code analysis through SonarCube, and then we can take a look and see if we're introducing risk to our, these systems that really require to be, they need to be stable and reliable.
We have another question about Topaz Workbench and does it have access to DB2 tables? And Topaz Workbench does have rich data editing capabilities, and Topaz Workbench integrates with FileAid, our FileAid product, and as I'm sure many of you are aware, our FileAid product is the de facto standard for editing data on mainframe. So you have access to DB2 tables and every other data source that exists on the mainframe to modify data, create data, edit data, view data.
And one thing that we'd be remiss not to mention is that when Steve was showing the Jenkins orchestration, you might have noticed a mention of ISPW. And at Compuware, we're pretty excited in that we purchased the assets of ISPW. And part of that was a natural evolution of our own development cycle. We previously were using a different SCM, and frankly, we were struggling to keep up with agile development using that SCM. So we reached out to ISPW. They helped us become much more agile in our source code management on the mainframe level, and it was one of those cases where we loved it so much we bought the company. I think, we didn't really get to all the questions, but I think the ones we didn't get to we'll handle offline, and we'd like to thank you for your time, and I think I'm going to pass it back to Janine.
Thanks, Jim. Those were great questions. I want to thank everyone for attending today's webinar, and I especially want to thank Jim and Stephen for sharing their expertise with us today. Later this week, our partners at Compuware will be sending out a link to a recording of today's webinar and additional valuable resources to everyone on the call, as well as to anyone who registered but for whatever reason could not attend. That concludes our webinar. Thanks again, and have a great day.